constraint, which is you have to locate a point and then you say tangent, so it'll stay tangent to that entity. And let me just select all and clear this. Let's draw two situations when geometry is intersecting and not intersecting. So in the first case, I will ask the software to put this at the intersection of these 2 points. And so if the intersection changes, it will change. In the second case, I can say make this line, I want to allocate the extended intersection. So the technique here is you click on the first point, slide the mouse over to the second entity and click again. Just release the mouse and it will find the intersection. Let's do it one more time. You click on the first entity, keep the mouse pressed and move the cursor to the second entity and release the cursor, and then your constraint is taken. Now if this geometry changes, you can see the virtual intersection is changing. And the last constraint type here is the slider. That means if I say that the point has a slide on this, then it will stay on the point here. So this is useful when you are creating mechanism and things. You want to have a sliding mechanism, and we will get into that a little bit later. So now that you understand the constraint types, there are, when you have the infer constraint on, then you can just, for example, if your geometry, if you want to create the second geometry, it will automatically detect the constraint endpoint or the midpoint or the endpoint. So let's say from the midpoint to midpoint here. So let's say I want to constrain a circle and it'll detect the tangency. If I go from here, it'll detect the origin. So constraints are detected, inferred automatically, but you can always select a manual constraint. For example, if I was going to come here, there are two constraints here. There is a midpoint constraint for the line which is highlighted, as well as the endpoint constraint for this line, which is the same point. So you can now select, say you wanted the endpoint constraint. So instead of making an error, you just click on the endpoint here and then click on the line and you'll get the endpoint. So you can always use a manual constraint at any time. And you can also use the manual constraint to allocate late constraint. For example, I drawn this line and now I want this point to be tangent to this, so I can come back and say give me tangent to this. And of course you can change the constraints at any time. Here this was at the end point of this line. Instead, if I clicked on this line here, it'll switch the endpoint constraint to the line of my choice. And you can also take away the constraint at any time. There are two ways of doing it. You can just click on the constraint and press the delete key and it'll remove the constraint. Or you could also select the constraint and click on the free point and it'll free up the constraint. And if a line has got multiple constraints, for example, I want a line from the end of this point to the center of this. So now there are two constraints in this line, so instead of freeing up them individually, you can just say unrelate and it will take away all constraints from that geometry. Another nice thing is that in our software you can have a constraint where the cause and effect are related. These are called circular constraints. It's kind of like a chicken and egg situation. If A changes, it affects B, but B in turn comes back and affects A. So these are resolved automatically. There's a very nice example of that. Let's say you have a shape here of some sort, and you put a circle inside, a hole inside the shape, and let's make it a rigid hole, by allocating it a radius constraint. So you can see the value bar here. This has been dealt later on in the calculations lesson, but I'm going to give a radius constraint. So I press the R key on the keyboard and say enter the radius I want. So the circle is, so that's fine. And now this circle can move around and be located any place. So now suppose I declare this to be an area, and then I say that the center of this circle is located at the centroid of this shape. This is a circular condition because if I move the circle, the centroid will change. So then the software has to iterate to resolve this circularity. So I just pick up the center and say make it at the center of this shape. So I pick up the centroid constraint here and click on the shape. So this is located now at the centroid of the shape. And if I change the shape now, you will see that the circularity is being iteratively solved. So the constraint intent is being maintained. So to summarize, you can allocate constraint using manual constraint or infer constraint. Once you have allocated a constraint, you can change it, you can delete it, and a little practice with the software will give you a pretty easy feel. It becomes almost like speaking to the software. It follows your commands the way you think. These have been dealt in greater detail in the section under lines, because lines, to constrain lines, there are multiple choices, and we have dealt with them in a separate section. But for right now, this should have given you a reasonable overview of the geometric constraints capability of our software. Thank you.